Hi everyone, welcome to Easy Service. From our last video on Traverse Computation Part 4, where we showed us on how to compute for the forward and the back bearing. Okay, we showed us on how to compute for the back bearing and the forward bearing between successive stations. All right, so if you are just joining us for the first time, please refer back to our video on how we did all that we've been doing so far. So this is just the part 5 on how to or compute for the correction to bearing between successive stations. So in this column, that is what we want to achieve. So we are going to be working with what we have here on this data sheet. So if you find out we came about this forward bearing between these two stations from photo 001 to photo 003 here. All right, so and these are two known controls. Okay, so if you find out we have a forward bearing between these two known stations to be 354 degree, 29 minutes, 32.93 seconds, and it is quite different from the corrected bearing or what we computed last, which is 354 degree, 29 minutes, 33.96 seconds. So the error now is what we want to distribute across these unknown stations. Okay, so and how to do that is just to compute the difference between the known corrected bearing and this uncorrected bearing. Okay, the known corrected bearing above and this uncorrected bearing below. So we are just going to punch that. So it will be the correct bearing, which is 354 degree, 29 minutes, 33.96 seconds. Then subtract, which is minus the uncorrected, which is 354 degree, 29 minutes, then 32.93 seconds. Okay, so we are going to be having this. So we're having 1.03 seconds, which is the error in bearing. So we are just going to write that down in this column here, which is 1.03 seconds. So what we'll be doing next is to add the sign. We want to add the sign, and how to note what sign is going to be added is just this trick. It's not a trick, but it's just the standard. All right. So you will find out that the uncorrected bearing, okay, it's less than the corrected bearing. So since it is less than the corrected bearing, then know that this error we are going to be adding it to this forward bearing here. So all you are going to be adding as a sign is the positive sign. So it's now going to be plus and not negative. So by the time you add this error here to this particular bearing, you are going to achieve the corrected bearing for this station as 354 degree, 29 minutes, then 33.96 seconds, which is the correct bearing, just like what we have above. So this error here is what we are going to be distributing across the unknown, and how to do that is just easy. So therefore, we are going to be using this that we have here as a formula. So what we have here is station ID, all right, over total number of station multiplied by the error. What that simply means is that the station ID is just the number of each station. So this is ID 1, photo 001 is ID 1, that is number 1. This peg 1 is number 2, peg 2 is number 3, and so on. So that is the station ID of each station. So this is 1, 2, 3, 4, 5 to the last. All right, so that is a station ID for this above. So total number of station is just all the stations you have, including your controls. All right, so total number of station is just 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, that's the total number of stations. So we are going to multiply that with the error. Error simply means error in bearing what we just computed below here, which is 1.03 seconds. So we are going to spread this error across each station. So just using this, all you have to do is to do the first correction to bearing for the first station, which is just the station ID for this is just 1 over, all right. The total number of stations, just like what we counted earlier, is 9. Then you multiply it by 1.03 seconds. So whatsoever you are having here is the error, okay, distributed for the first forward bearing, which is the first bearing of the first station. So we are just going to compute that with our calculator. So therefore, there we go. So the station ID is 1 all over 9 multiplied by 0 degree, 0 minute, 1.03 seconds. Then you can just punch it equal. So on the first station, we are having 0.11 seconds as the error distributed for that station. So we are just going to write that down at this column here plus, remember why it is plus 0.11 seconds. Okay, so we are just going to do the same thing for the second station. So you don't need to start doing much, just you just have to edit the ID, the station ID all through. So here is 0.23 seconds, so plus 0.23 seconds for the station, and for the next station just keep editing, and here is 0.34 seconds. Then we are going to write that plus 0.34 seconds. So that is the same way we are going to do for all the stations by just editing the station ID, then multiplying it. We are going to have the error for each station. So therefore, at the eighth station ID, so I'm having 0.92 seconds. So I've just bent that down. Then if you now check for the last station, which is 9, all you are going to be having back is our 0 point, that is our 1.03 seconds. So I'll just pen that down, which we've done earlier on. So all you have to do now is just to add this error to each forward bearing. Just add 0.11 seconds to this. You are going to be having the corrected bearing for the station. So now this is the final bearing for the forward computation, and you are just going to, so if you check what we have here, all right, there are some scholars or surveyors who loves to approximate this point, the decimal, okay, to a whole value. So at this particular seconds, they don't like leaving it in decimals. So any particular value, or any particular value after the decimal that is above 30, that is above zero point 0.5 rather, any decimal that is above zero point 0.5, they do approximate it to 1, then they add it to the value before the decimal. So let's say you have something like this. Here it is 24.62 seconds. So some scholars do approximate this to 1. So what you are going to be having here is 25 seconds. So here like this, that we have 52.45 seconds, they will approximate this to, if you are going to approximate it from our basic understanding of mathematics, here you'll be having 52.5, which is still approximate to 1. then here you'll be having 53 seconds. But in the course of this video, I will not be approximating not to cause confusion. So we are just going to be using it that way. So that is how we are going to be adding this error to the forward bearing to have the final bearing. So therefore, as you can see, we've successfully added each error into the forward bearing to have the final bearing for each stations, just like that. So in our next video, we are going to show you on how to get the partial coordinates or the delta eastings and delta northings. That is the delta northings here on this column and the delta eastings on this column before we can now get the arithmetic sum and the whole other stuff. So thank you for watching. Don't forget to hit on the subscribe icon and the notification bell to keep encouraging us. See you next time.